So this is a help video for the Equilibrium Lab in Chem 112. And I'll pull up, let me just pull up so there is the laboratory. And in fact, what we're going to talk about here is the pre-lab. So that is calculations of this type that we're going to do. But this is for a particular reaction as outlined in the laboratory itself. It is iron 3+, an aqueous solution, reacting with thiocyanate, SCN-, to produce what's called the complex ion, iron thiocyanate. The NCS has a -1 charge. Iron has a 3+ charge. That doesn't change, and so the net charge is +1. And then you're asked to calculate the equilibrium constant in this reaction. And to do that, you're going to measure this concentration. That is what you measure through spectrophotometry. And then you prepare initial solutions of iron 3+ concentration and thiocyanate concentration. And then you use stoichiometry. And what you want to notice is there's a 1-to-1-to-1 relationship. So you measure ultimately what concentration this you make. And because every one of the iron thiocyanates uses 1 mole or 1 atom of the iron and 1 atom or molecule in this case or mole of thiocyanate, you can calculate, given the initial concentrations, what the final concentration is. At equilibrium, then you plug these in and you calculate what this is. Now that's what the purpose of the lab is to do. Measure iron thiocyanate by spectrophotometry, make initial concentrations of iron 3+ and thiocyanate. Because 1-to-1 correspondence occurs, if you start with a concentration of, for example, 1 molar, and you know you end up making 0.1 molar of this, we start with 1 molar, we know we use up 0.1 molar, subtract 0.1 molar, and it tells you the final concentration is this. And that's what goes in here and what goes in there. And I'm going to walk you through those calculations. That's what the pre-lab is meant to do, but that's the basic purpose of the lab. So we measure this by spectrophotometry. We calculate what those must be through a procedure that's pretty standard for doing equilibrium concentrations. Now that's the basic idea. Let's do the pre-lab. So the first calculation you have to do is just what are the concentrations of each of these. So you want to complete this following table and transfer it to table 1 to do in your laboratory. Now these are very standards. We'll do this for solution 2, and all you're doing is, because we take 0.2 milliliters and we know the molarity, we can calculate how many moles we have. So let's just run through that calculation. It's real straightforward. So let me get this pen turned on again. And, for example, solution 2, so we have 0.20 milliliters. Well, that equals 0.02 milliliters, 0.02 liters then, times the molarity of that solution. It tells you it is 0.002 moles of the NaSCN per liter of solution. Multiply those together, and that tells you then what the number of moles. And for example, this one, turn the pen on again. This one is 4 times 10 to the -6, and that's the number of moles, not molarity. And then we do the same thing for iron nitrate, and that's going to be 2.5 milliliters, so that becomes 0.0025 liters times the molarity of iron nitrate, which is 0.2 moles per liter. That turns out to be 5 times 10 to the -4th. Again, that's moles now, in this case, of the Fe3+. Now, the only thing, okay, so so far we have 0.2 milliliters. We've